I want to find the area of the surface from revolving this curve over the interval 0 to pi and the polar axis. So what I need is, remember for the polar axis, I need f of theta sine theta. So I'm going to need a times 1 plus cosine theta sine theta. I need to know what this squared is. This is a squared times 1 plus cosine theta squared, which is a squared times 1 plus 2 cosine theta plus cosine squared theta. The derivative of this is negative a sine theta. Squared is a squared sine squared theta. And if I add these two together, I have a squared on the outside, and I have 1, and this equals 1. So I have 2 plus 2 cosine theta, or 2a squared times 1 plus cosine theta. So now I have s is 2 pi, the integral from 0 to pi, of this a times 1 plus cosine theta times sine theta times the square root of 2a squared times 1 plus cosine theta, all d theta. So I'm going to move some stuff around. I am going to bring this a out here. I'm going to take out a radical 2 from here. And so this is the same as a radical 2 times 1 plus cosine theta to the 1/2. So I have 2 and then a radical 2, a pi. So I got rid of this, oh sorry, a squared, because I have this a and that a, so it's a squared, 2 radical 2 pi. And on the inside I have from 0 to pi of sine theta times 1 plus cosine theta, and I have it to the 3/2, because I have it to the first plus 1/2, that's 3/2 d theta. So I can use u substitution, and u is 1 plus cosine theta, and then du is negative sine theta. So this equals the negative of 2 radical 2 a squared pi times 1 plus cosine theta to the 5/2 times 2/5, all from 0 to pi. So I have 2 times 2 is 4. I have negative 4 radical 2 over 5 a squared pi times 1 plus cosine of pi to the 5/2 minus 1 plus cosine of 0 to the 5/2. Well, this is negative 1, so this whole thing becomes 0. This is 1, so that's 2. And that's the same as 2 to the 5/2 is the same as 4 radical 2. So now and the whole thing is negative 4 radical 2. So a negative 4 times negative 4 is 16, times 2 is 32, so I have 32 over 5 a squared